It was 1976. Deep inside a Soviet PVO Strany air defense bunker near Murmansk, a radar operator stared at his screen in disbelief. A single blip was crossing into Soviet airspace at an altitude that shouldn't exist. 85,000 feet. The operator called his commander. They scrambled 2 MiG-25 interceptors, the fastest jets the Soviet Union had ever built. The pilots climbed to their absolute ceiling, afterburners screaming. They locked their missiles. They fired. And they watched in horror as the American aircraft simply accelerated away from the warheads. It didn't turn. It didn't dive. It just flew faster than their missiles could chase. In that moment, the most advanced air defense network on Earth was rendered completely useless by a single black aircraft. This was one of the greatest mysteries of the Cold War. Soviet generals asked the same question for years. What is this thing, and why can't we stop it? For Soviet intelligence, the SR-71 Blackbird was a nightmare. But in the beginning, it was merely a legend. In the early 1960s, the American high-altitude reconnaissance aircraft U-2 was the undisputed master of Soviet airspace. CIA pilots flew over Moscow, photographed nuclear facilities, and Soviet air defense could do nothing about it. The U-2 flew too high. Soviet missiles couldn't reach it. Until May 1, 1960. On that day, a CIA pilot named Gary Powers was flying over Sverdlovsk when a new Soviet SA-2 missile finally reached its target. The U-2 was shot down. Powers ejected and was captured. The Soviets declared victory. Khrushchev announced that the end of American imperialism had arrived. But while celebrations continued in the Kremlin, deep in the Nevada desert, at Lockheed's secret facility known as Skunk Works, engineers were already working on the next generation. The successor to the U-2, but this time it wouldn't just fly high. This time it couldn't even be chased. The project began as the A-12, then it became the YF-12, and finally, in 1964, the SR-71 Blackbird was born. The engineers, led by Clarence Kelly Johnson, had achieved the impossible. A machine capable of flying at Mach 3+, at altitudes of 85,000 feet. Faster than a rifle bullet, nearly 3 times the altitude where commercial aircraft fly. The Soviets were aware of this aircraft's existence. Their spies had brought back dark photographs and vague reports. But no one truly understood what it was. They couldn't. Because the SR-71 violated every engineering rule that existed at the time. The year is 1967. At the Soviet Air Defense Command in Moscow, generals have gathered for a classified briefing. On the table, radar traces captured over the past few months are spread out. They all show the same thing. An unidentified object moving at incredible speeds at the edge of Soviet airspace, sometimes inside it. "This is impossible," said a colonel, examining the radar data. "No aircraft can maneuver at this speed, at this altitude. Perhaps it's a meteor. Perhaps an atmospheric anomaly." But it wasn't a meteor. Meteors don't take photographs. A few weeks later, GRU agents delivered a disturbing report. The Americans possessed crystal-clear photographs of Soviet nuclear submarine bases, ICBM silos, and secret radar installations. These photographs were taken from directly above, not from space, but almost from space. And worst of all, Soviet air defense hadn't detected any of these flights, let alone stopped them. Soviet leaders were furious. Billions of rubles had been spent building the world's most dense air defense network. Thousands of radar stations, hundreds of interceptor aircraft, tens of thousands of missiles, and a single American aircraft was entering and leaving as if none of it existed. Defense Minister Andrei Grechko slammed his fist on the table. "Stop this aircraft, whatever the cost." And so began one of the most expensive and unsuccessful hunting operations of the Cold War. The Soviets first deployed the MiG-25 Foxbat. This aircraft was specifically designed to stop the SR-71. Soviet engineers were obsessed with speed. The MiG-25 could reach Mach 2.8. Theoretically, it could push to Mach 3.2, but that would melt the engines. Still, it was the fastest interceptor in the world. In 1973, a dramatic encounter occurred. An SR-71 was conducting a reconnaissance flight over the Barents Sea. Soviet radars detected it. Two MiG-25s launched with full afterburner. The pilots knew their orders: shoot down this aircraft at any cost. The MiG-25 pilots climbed 20,000 meters, 22,000 meters, 23,000 meters. The engines were operating at their limits. Fuel was depleting rapidly, and the SR-71 was still above them, still pulling away. One of the Soviet pilots achieved radar lock. He fired his R-40 missiles. The missiles launched, leaving white smoke trails as they climbed into the sky. The pilot held his breath. The missiles climbed, and then they ran out of fuel. Unable to reach the SR-71, they succumbed to gravity. The American aircraft didn't even turn. As if unaware of what was happening behind it, it continued on its course and disappeared over the horizon. That night, the Soviet pilot wrote his report. His hand was trembling. Target was outside missile range. Intercept unsuccessful. But the reality was far worse. The Soviets weren't just failing to hit the SR-71, they couldn't even catch it. If you want to discover Cold War stories and secret technologies, don't forget to subscribe to our channel. We bring you new content every week. As Soviet engineers tried to understand how the SR-71 could fly so fast, they encountered a fundamental physics problem: friction. When an aircraft flies at Mach 3, air friction heats the fuselage to extreme temperatures. The temperature at the SR-71's nose exceeded 300 degrees Celsius. The wing edges approached 500 degrees. At these temperatures, aluminum melts, steel weakens. A normal aircraft would literally disintegrate in mid-air. Soviet analysts ran calculations. The results were illogical. "This aircraft cannot fly at this speed," said the chief engineer. "Material science doesn't allow it." But it was flying. Every week, sometimes every day, it appeared at Soviet borders, taking photographs, gathering intelligence, and disappearing. The Soviets activated their spy networks to find the answer. The KGB tried to place agents in every American aerospace company. The GRU analyzed captured technical documents. And slowly, the terrifying truth began to emerge. The Americans had used titanium. This might seem simple today, but in the 1960s, working with titanium was nearly impossible. The metal was extremely hard. Normal tools couldn't cut it. Welding required special techniques. And the greatest irony? The world's largest titanium supplier was the Soviet Union. The CIA had purchased titanium from the Soviets through front companies. The Soviets, unknowing that their own metal would be used against them, had supplied raw materials to their enemy. 85% of the SR-71's fuselage was made of titanium. This metal maintained its strength even at 500-degree temperatures. Moreover, it was lighter than steel. The Americans had solved the material science problem that the Soviets couldn't crack, using the Soviets' own resources. But speed and altitude weren't the only advantages. The SR-71 had another secret: radar cross-section. Soviet radars could see the SR-71, yes, but what they saw was strange. The signal was weak, indistinct. Sometimes the aircraft appeared as small as a car, sometimes like a bird. Sometimes it disappeared entirely. Soviet radar engineers were going mad. The system must be malfunctioning, they said. They calibrated their equipment. They tested new radars, but the result was always the same. The SR-71 slipped through radar like a ghost. The reason was that the SR-71 incorporated the world's first stealth design elements. Kelly Johnson's team had designed the aircraft shape to scatter radar waves. The fuselage was shaped with smooth curves rather than sharp angles. The engine inlets were positioned to prevent radar signals from entering and bouncing back out. And the black paint. The SR-71's characteristic black color wasn't just aesthetic. This special paint contained a radar-absorbing material called iron ball. Small iron-based spheres absorbed radar waves and converted them to heat. The Soviets didn't understand this technology. The concept of stealth didn't exist for them yet. They couldn't conceive that radar could lie, that an aircraft could appear smaller than it actually was. So they decided the problem was with their own systems. They spent millions of rubles upgrading their radar networks. But the SR-71 still slipped through like a ghost. Soviet intelligence finally managed to obtain technical schematics of an SR-71. An agent at an American aerospace firm photographed classified documents. When the documents reached Moscow, the engineers were left in shock. "This doesn't make sense," said the chief analyst. "Look at this aircraft's fuel system. It must be leaking fuel while sitting on the runway." He was right. The SR-71 actually did leak fuel while on the ground. This wasn't a design flaw, it was intentional. At Mach 3, the aircraft's fuselage expanded. Metal grew larger as it heated. The engineers knew this, so they designed the fuel tanks to not seal completely when the aircraft was cold. Fuel leaked on the ground, yes, but in the air, when the fuselage heated and expanded, the tanks became perfectly sealed. This was the reverse of traditional engineering thinking. The Soviets didn't think this way. For them, if a tank was leaking, it was a problem, a malfunction that needed fixing. It took years to understand that the Americans had used leaking as intentional design. And the fuel itself was a special problem, JP7. This fuel was so stable that if you dropped a match into it, it would go out. Normal jet fuel could ignite during flight, but JP7 was resistant even to extreme heat. It had been specially developed because normal fuel would spontaneously combust in the SR-71's fuel tanks. The Soviets spent years trying to crack the formula of this fuel. They failed. The chemical composition of JP7 remains classified to this day. By the mid-1970s, Soviet air defense was in full mobilization. The moment an SR-71 was spotted, the entire region went on alert. Missile batteries prepared to fire. Interceptor aircraft took off. Radar operators never took their eyes off the screens. And still, they failed. According to official records, more than 4,000 missiles were fired at the SR-71 fleet. The number is disputed. Some sources give lower figures. But one thing is certain, not a single SR-71 was ever shot down by enemy fire. Zero. Throughout 25 years of operational service, not a single loss. This statistic drove Soviet generals insane. How could this be? The world's most dense air defense network couldn't stop a single aircraft? The problem was multidimensional. First, the SR-71 flew too high. It was above the effective range of SA-2 missiles. Second, it was too fast. Even if missile lock was achieved, by the time the missile reached the target area, the SR-71 had already moved out of range. But the biggest problem was mathematics. For a missile to hit a moving target, it must calculate where the target will be in the future. This calculation takes seconds for normal aircraft. But for a target moving at Mach 3, the calculation time exceeds the missile's flight time. By the time the missile is fired, the SR-71 is already somewhere else. Soviet engineers developed new missiles to solve this problem. Faster missiles, missiles that could climb higher. But for every new missile, SR-71 pilots developed new evasion maneuvers. Usually the simplest one, fly faster. There was a joke among SR-71 pilots. What do you do when the missile warning system goes off? Step on the gas. The year is 1986. Tensions between the US and Libya were escalating. The Reagan administration was evaluating military options against Gaddafi's terror-supporting activities. But first, they needed intelligence. The SR-71s were called in. One April morning, 2 SR-71 Blackbirds took off from Mildenhall Base in England. Target, the Libyan coast. Mission, photograph defense systems, military bases, and Gaddafi's possible locations. Libya was equipped with Soviet-made SA-5 missiles. These missiles were far more advanced than the SA-2s. Longer range, better targeting. The Soviets believed the SA-5s could hit the SR-71. They were wrong. As the SR-71s passed over Libya, missile batteries opened fire. 6 SA-5 missiles launched. The pilots heard their warning systems screaming. Standard procedure kicked in: accelerate and climb. The aircraft pushed to Mach 3.2. The missiles fell behind. Within minutes, the SR-71s had reached safe airspace. Behind them, they left millions of dollars worth of missile wreckage and Libyan air defense commanders driven to fury. The next day, the photographs taken by the SR-71s were in Washington. Images of perfect clarity. Every military installation in Libya, every radar station, every missile battery had been mapped. A few weeks later, the U.S. launched an airstrike on Libya. Operation El Dorado Canyon. The attack plans were based on SR-71 photographs. When the Soviets couldn't stop the SR-71, they tried to copy it. The MiG-31 program, a more advanced version of the MiG-25, was accelerated. Higher ceiling, better radar, longer-range missiles. But the real answer never came. Soviet metallurgy, titanium processing capacity, never reached American levels. Soviet electronic systems couldn't match the SR-71's avionics. And most importantly, Soviet fuel technology couldn't crack the secrets of JP-7. This technological gap was a nightmare scenario for Soviet leadership. The SR-71 wasn't just a reconnaissance aircraft. It was a symbol of American technological superiority. Every failed intercept attempt, every escaped target, was proof of the Soviet system's inadequacy. By the mid-1980s, some Soviet generals began to quietly admit, defeating the SR-71 is impossible. We have to live with it. This admission was one of the greatest psychological victories of the Cold War. The Soviets understood that they couldn't compete on air superiority. This understanding shaped their subsequent military strategies. If you can't stop the aircraft, hit the command centers. Target the bases that train the pilots. Take the war to a different dimension. The year is 1990. The Cold War was ending. The Berlin Wall had fallen. The Soviet Union was on the brink of collapse, and the SR-71 fleet was being retired. The official justification was economic. Each flight hour cost more than $200,000. Aircraft maintenance had reached astronomical figures, and new satellite technology could perform the same reconnaissance missions more cheaply. But some proposed a different theory. The SR-71's successor was already ready, a secret hypersonic reconnaissance aircraft codenamed Aurora. This aircraft flew at speeds the SR-71 couldn't even dream of. Mach 5, maybe Mach 6. This theory was never confirmed. Aurora remains one of the greatest mysteries in aviation history. The SR-71s were moved to museums. The pilots retired. But the legend lived on. The SR-71 Blackbird was one of the most extraordinary machines humanity has ever produced. This aircraft, designed 60 years ago, still holds the records. It still possesses speed and altitude records that no manned aircraft has been able to surpass. For the Soviets, it was a nightmare, a ghost they tried to hunt for 25 years, that they couldn't catch, that they couldn't hit. More than 4,000 missiles, 0 hits. This statistic summarizes the most dramatic technological asymmetry of the Cold War. But the SR-71's true legacy isn't in the numbers. This aircraft represented a philosophy. There is no such thing as impossible, only problems that haven't been solved yet. Kelly Johnson's team questioned every engineering rule. Fuel tanks that leak? No problem. They seal when the aircraft heats up. Melting metal? Use titanium. Being seen by radar? Change the shape. Hide with paint. This way of thinking forms the foundation of today's stealth technology, hypersonic vehicles, and spaceplanes. That radar operator in Murmansk, on that night in 1976, witnessed something that changed the course of history. That small dot on his screen wasn't just an aircraft, it was a symbol of an era. the symbol of the moment when one superpower made the other acknowledge its technological superiority. And the missiles still couldn't catch up.